One summer day, the high temperature was 103 degrees Fahrenheit and the low was 69 degrees Fahrenheit. The temperature throughout the day can be modeled by a sine or cosine graph, where y represents the temperature in degrees Fahrenheit and t represents the hours after 3 a.m. Find each of the following. Okay, so the amplitude is the high of the graph minus the low of the graph over 2. So in this case, that is 103 minus 69 over 2, which is equal to 17. The period is going to be our 2 pi over b, if we remember that from our formula. So we need to figure out how long it takes for it to go through one whole cycle. So in this case, our period is 24. It takes 24 hours. Our midline is going to be the center point here. So in this case, it is our lower point, 69, plus our amplitude, 17, which is equal to 86. B, we're going to write an equation for the graph in terms of both sine and cosine. So we know that our b, or our period, is 2 pi over b. So 24 is equal to 2 pi over b. So b is going to be equal to pi over 12. Now, we know for cosine, we're starting right where we want to start, but at the bottom instead of at the top. So we know that for our cosine graph, that's going to be negative because we're starting at the bottom versus the top. And then our amplitude, A, 17, times the cosine. Now we know our B is pi over 12. And it doesn't shift at all, so that's just our T. Plus, now we have to move it up to our midline, so 86. Now for our sine graph starts right there. So as you can see, we moved over 6. So our sine graph starts there and goes up first. So it's going to be positive 17 times the sine of pi over 12 times t minus 6, because we scooted over 6, plus 86. A transformed tangent function has vertical asymptotes at every odd integer and passes through the points 0, 1, and 0.5, negative 3. Find possible formulas in the form f of x is equal to a tan bx. The first thing we're going to look and see is where our origin is usually at 0, 0, and where it is now. We can see that it's up 1 more than now, so that makes our k equal to 1. We can also see from looking at this graph that it's reflected over the x-axis. So we know that our a is definitely going to be a negative number because it's reflected. So normally, our graph is going to hit 1 up from our next point there. Here, it goes over 4, because the difference between 1 and 3, negative 3 minus 1 over 1, is equal to negative 4. So that's what our a is going to be, our negative 4. Now, to find b, we need to figure out our period, because we know our period, in this case, is equal to pi over b for a tan graph. So our whole period is going to be, if we just look from asymptote to asymptote, 2 units. So we know b is equal to pi over 2. So our answer is going to be f of x is equal to negative 4 tangent of pi over 2 x plus 1. Moving on to number 26, we're going to find the period for each of the following functions. So we know that this is b, and for tan functions, our period is equal to pi over b. So if we know our b is 1 over 8, then p is equal to pi divided by 1/8, which is equal to 8 pi for part A. For part B, our period is back equal to 2 pi over b because it's not a tan function. We're back to a cosecant function. So our b here, though, is 2/3. So p is equal to 2 pi divided by 2/3. These 2's can cross out, and we're left with 3 pi. All right, we are going to simplify these as much as possible. So the first one we have is tangent theta, cosecant theta. So we know that tangent is sine theta over cosine theta. And cosecant theta is 1 over sine theta. When we're able to cross out these thetas, we get 1 over cosine theta, which is the same thing as secant theta. Moving on to part B, we have cosine of x plus sine of x squared minus 2 cosine x sine of x. So the first thing we're going to do is expand this out to get cosine squared of x plus 2 sine x cosine x plus sine squared of x minus 2 cosine x sine of x. You can see that these two go away, and you're left with cosine squared of x plus sine squared of x, which is equal to 1. For the next one, we have 1 minus cosine squared of x times 1 plus cotangent of x. So we know that using our identity that 1 minus cosine squared of x is the same as sine squared of x. And 1 plus cotangent squared of x is the same as cosecant squared of x. So coming over here, that is sine squared of x times 1 over sine of x squared. This square goes to both terms, so these guys end up canceling out, and we also get 1 here. And on to number 28, we're going to show that secant of negative x minus cosecant or cosine of negative x. We're just going to start with this side because we're showing it's equal to this side. We know that these are both even functions, therefore the secant of negative x is just equal to the secant of x, and same with the cosine of negative x, just equal to cosine of x. Now we're going to rewrite secant as 1 over cosine of x minus cosine of x. We're going to go ahead and make a common denominator, so that gets us 1 minus cosine squared of x over cosine squared of x. The next thing we do is we know that 1 minus cosine squared of x is equal to sine squared of x. So that gets us sine squared of x over, this cosine here isn't squared, it's just a regular cosine because we multiply this by cosine x over cosine x over cosine of x. We know that 1 sine over cosine is a tangent of x. Then we're left with a sine of x on top. Now we're going to express tangent in terms of sine. If t is between pi over 2 and pi, we know that tangent of t is equal to sine of t over cosine of t. We're going to use the quotient identity since cosine of squared of t plus sine squared of t is equal to 1. That means that cosine squared of t is equal to 1 minus sine squared over t. That means that cosine of t is equal to the square root of, plus or minus the square root of 1 minus sine squared of t, We know that within negative pi over 2 to pi, cosine's negative. So that tells us that our cosine of t is going to be the negative version of the square root of 1 minus sine squared of t. Then our tangent of t will be negative sine of t divided by the square root of 1 minus sine squared of t. A security camera is mounted on a pole 9 feet above ground level. What angle of depression should be used if the camera is directed at a spot 4 feet above the ground and 16 feet away from the pole? So that means that this triangle here, if I draw it, this distance is going to be 16 still, but this distance is going to be 5 because I'm doing that little line there, which is 9 minus 4. What angle of depression, which we know is going to be this angle right here, should we use? We know that angle. Oh no, I'm so sorry, guys. We know that angle is equal to this angle. So that tells us that tangent of 5 over 16 is equal to theta. Then we'll find the inverse tangent of 5 over 16. Sorry, tangent of theta is equal to 5 over 16. Which gets us equal to 17 degrees, around there. Moving on to finding the exact values of the following. We know that the inverse cosine of negative 1 over root 2, using the unit circle, you know that that itself is equal to 3 pi over 4. Then we have to find the cosine of 3 pi over 4, which is equal to negative 1 over the square root of 2. Moving on to part B, we're first going to start by finding the sine of 4 pi over 3, which using your unit circle, you get negative root 3 over 2. Now we're going to find the arc sine of negative root 3 over 2. And within the bounds of arc sine, that becomes negative pi over 3. Next, we're going to find the cosine of the arc sine of negative 1/2. So again, this is all going to be using your unit circle. Your arc sine of that is going to be negative pi over 6, falling within the bounds of arc sine. The cosine of negative pi over 6 is going to be equal to root 3 over 2. Last one, we're going to find the tangent of 3 pi over 4, which using the unit circle, you know is negative 1. Now our arc sine of negative 1 is going to be equal to negative pi over 2 because it's at the bottom of the unit circle. All right, now we're going to simplify and give an exact value, starting with the arc cosine of 20 over 29. We're going to go ahead and draw a triangle here. We know that this cosine, if we call this guy theta, is going to be our adjacent over our hypotenuse, that's 20 over 29. And we're looking for the tangent of this theta, because this theta is the arc cosine. So the tangent of this theta is going to be the opposite over the adjacent, so 20. So we need to figure out what this value is. We'll use our Pythagorean theorem. To solve that b is equal to 21, right? Because this is going to be 400 plus b squared is going to be equal to 29 squared, which is 841. So b squared is equal to 441. That's how you get b is equal to 21. So our tangent theta here is going to be 21 over 20. And we're going to do the same thing for part B. Oops, so sorry. So if I have this theta here, we know that our arc sine, so like our sine, is going to be 3 over x. So that is my opposite here, 3 over my hypotenuse, x. So there's our triangle, and we're looking for the secant. The secant is 1 over the cosine. So our cosine is going to be our adjacent over our hypotenuse. So to solve for our adjacent, same thing as last time, 3 squared plus a squared is equal to x squared. A squared is equal to x squared minus 9. A is equal to the square root of x squared minus 9. So now our cosine of that, cosine is going to be our adjacent, x squared minus 9, divided by our hypotenuse, which is x. That gives our secant as x over the square root of x squared minus 9. On to 33. Solve the equation on the interval 0 to 2 pi. Show your work including reference angles or other angles used to find the solution. So we have 3.5 sine x minus 1 is equal to 8 sine x plus 2. So the first thing we want to do here is we want to get all of our constants on one side by subtracting this 2. And all of our signs on one side by adding this sign to both sides. So that gets us negative 3 is equal to 4.5 sine of x. That tells us that sine x is equal to negative 3 divided by 4.5. If we go ahead and put the inverse sign of negative 3 over 4.5 into our calculator, we'll get that as negative 0.7297 is equal to x, but that's not within our bounds. So that is right here, this negative 0.7297. Now we're going to want to go ahead and add 2 pi, which will get us 5.5534. We now know that our second answer within this interval is going to be our x1 plus pi, which gets us 3.87132. So our two answers are going to be 3.87 and 5.55 because those are the two within the correct interval. All right, since we have a cosine squared in our next one, we're going to want to get all the terms onto one side. So 2 cosine squared x plus 3 cosine x plus 1 is equal to 0. If we make like a little u substitution and say that u is equal to cosine of x, we can solve this as 2u squared plus 3u plus 1 is equal to 0. That will factor out into 2u plus 1 times u plus 1. So that gives us our two answers in terms of u. Our u is equal to negative 1/2 and u is equal to negative 1. We know that cosine is equal to u, so cosine of x is equal to negative 1/2. Cosine x is equal to negative 1. This tells us here, if cosine x is equal to negative 1 over here, that tells us that x is equal to pi. Here, we need cosine of x to equal negative 1/2. So we know that's going to be somewhere right here. This is negative 1/2. We know that our two answers are going to be here and here. So this angle right here is going to be whatever gets us cosine of -1/2, so that's 2 pi over 3. And this angle over here is going to be the second angle that gets us that, so 4 pi over 3. So those are our 3 answers there. Consider the equation sine theta is equal to a. There are 2 values of a that each cause the equation to have exactly one solution on the interval 0 to 2 pi. What are those values of a? So on 0 to 2 pi, the only ones with exactly one solutions are where sine's equal to 0. So there and there. So a is plus or -1. So now we have the function p is equal to pt, and it represents the population of an Oklahoman town at time t measured in years. The practical term of the meaning of dp over dt is the rate of change of the population with respect to time. Next, for several years in the 1930s and 1940s, dp over dt was a negative number. What was happening to the population during this time? It was decreasing, because if the change is negative, it's a decrease. For a short while, dp over dt was 0. What was happening to the population during that time? It was staying the same. The graph of the function y is equal to f of x is given. Identify regions where the rate of change is positive, negative, or 0. So positive here is going to be when we're going upwards. So that's going to be from -infinity to -1. Our negative is going to be where we're going downward, so the whole other side of this graph from -1 to infinity. And our dy dx is 0 at x is equal to -1, because that's when our rate of change is a tangent line, constant. Use this information to determine which of the graphs below could be the rate of change. So we can see that we go from a positive rate of change to a negative rate of change. And the only one of these graphs that goes from positive to negative is C, with 0 being at -1.